Assalamualaikum warahmatullahi wabarakatuh. Bismillahirrahmanirrahim. Nama saya Muhammad Daffa Balao, PM 220606159. Dan hari ini saya akan uh, menjelaskan dan membahas tentang satu uh, problem dari mechanical fluids. And of course, dengan membahas soal ini, we'll go through it with the classic DAI5 method. So, okay. Of course, di DAI5 pasti selalu ada intention, initial thinking, idealization, and instruction set. So we'll get our intentions out of the way first and we'll get our intentions set straight. So our intention is, of course, to solve the mechanical fluid problems and also not forget that our ultimate intention is to get and understand God more from it because as everything else is in this world, everything is from God and back to God. So by doing these problems and understanding about these subjects and everything more, we'll appreciate God more from it and we'll start to understand more and start to be thankful to God more because of it. Okay, let's move into the problems itself. So let's consider a problem that's 1 times 2 millimeter sheet of plywood is attached to the vat of your vehicle after being purchased at the hardware store. And at what speed, and it asks in kilometer, will the boundary layer fits start becoming turbulent? And at what speed is about 90% of the boundary layer is turbulent? Oh, sorry, it just says to the roof. So, okay, uh, we'll move on to our initial thinking. The data that we were given in this particular problem is that the plywood sheet itself, so we can set it the plywood sheet, and this is 1 millimeter times 2 millimeters. This is 2 millimeters, 1 millimeters, and we were asked to determine the speed when the boundary layer first start becoming turbulent, and at what speed is about 90% of the boundary layer turbulent. And we can get that the L for the plywood itself is 2 meters. Oh, sorry, this actually this plywood, this not this. This is wrong. So this is 2 times 1 meter. So the L is 2 meters. And we'll move on to the idealization. To solve this problem, we can assume that the air's temperature will be somewhere standard at around 20 degrees Celsius, and the critical Reynolds number above which the boundary layer will become turbulent is the Reynolds numbers of 5 times 10 to the power of 5 for the external flows of fluid. So once we assume that the air is 20 degrees Celsius, then the density itself and dynamic viscosity we can search in the table, which is 1.221 kilograms per meter cube, and the viscosity is and dynamic viscosity is 1.81 times 10 to the power of negative 5. And then we can calculate the velocity of the vehicle with the Reynolds number, and we can modify the Reynolds number formula, and we'll get the formula for the velocity itself. Now we can move on to the instruction set. So we can calculate and uh, solve these problems with the data we obtain. So the Reynolds number is R equals rho times V times L per mu. So we can get to the formula of the Reynolds number itself. The formula for the Reynolds number is R equals rho times V times L divided by mu. And we can configure that formula so we'll get the V equals RE times mu divided by L and rho. So we can input all the data that we got from the initial thinking and idealization phase, and we'll get that the Reynolds number itself is, oh, we can get the velocity since we're searching for the velocity, is 3.74 uh, meter per second, and that is 13,464 kilometers per hour. And so that's the velocity, and that's for number A. And in order to determine the velocity at which 90% of the flow will be turbulent, we'll have to assume the length of the laminar flow is 10% of the total flow. And you can consider this, you can argue that this goes back to the phase of idealization because we're assuming again and we're idealizing it again. But for the sake of the continuity, uh, we'll keep it straight. So we'll assume that the length of the laminar flow is 10% of the total flow. Therefore, length, the the new length is 2 meters times 0.1 is 10%. So the new length is 0.2 meters. And we can get the new velocity for when it's 90% turbulent. And we'll put the new length here. And if we calculate it the same way, but we replace the length with 0.2, we'll get that the velocity is 37.4 meter per second or 134.64 kilometers per hour. I should note that this is 13.464, not 13,000. So these are the velocities for this particular plot problems. 13.1464 kilometers per hour and through 134.64 kilometers per hour. So that's all for this particular problem. If there's any miscalculation or mishap that I might have done, you can put them in the comments and give your opinions. And if there's any question, of course, you can put them in the comments also. And for that, thank you so much for watching, and uh, I'll see you in the next video. Assalamualaikum warahmatullahi wabarakatuh.